Bismillahirrahmanirrahim. Assalamu alaikum, dear students. I'm Arif and I welcome you all in today's session. To access the notebook for today's session, you can access course page Arif taught me. You can click the appropriate link under the lecture resource column to open the notebook in NB Viewer and run it online in Binder. The other ways to download the notebook is from the course GitHub repository, Arif PVCID. And all the notebooks for this course are housed in the public data science repository, data science over here. Well, this is the Jupyter Notebook dashboard running locally on my machine at port 8888. And this is the notebook for lecture number 3.21 of the third module, Python Programming for Data Scientists, for the course titled Tools and Techniques for Data Science. Well, today we will have our first session on data visualization. Making informative visualization, sometimes called plots, is one of the most important tasks in data analysis. During exploratory data analysis, it helps identify outliers, help in making out comparisons, identifying hidden trends in data, and so on. During the project deployment phase, interactive visualizations also comes very handy when we want to communicate our results with the clients. My dear friend, we will be using Python's Matplotlib and Seaborn library for these tasks. And please do make some time to give a bird's eye view to Matplotlib user guide by clicking the appropriate link. Great. Well, my dear students, a picture is worth 1,000 words, and with Python's Matplotlib library, it fortunately takes far less than 1,000 words of code to create a production quality graphic. Unlike computers, humans are visual beings. For example, by merely looking at this tabular data shown in this Excel file over here, you cannot identify patterns, trends, and insights. On the contrary, it becomes quite easy if the same data is visually displayed in some appropriate type of chart or graph. There are around 40 different types of charts that one can use, like a line graph, a bar plot, a scatter plot, a pie chart, maybe a box plot, a histogram, and so on. And with this, I come up to $100 question, and that is which chart to use in which scenario. My dear students, Dr. Andrew Abela published this diagram that can help decide about which chart are the better fit for a given data and problem at hand. Well, if you want to compare values and analyze trends, line graph, bar graph, and column graph should be your first choice. And if you want to show composition of something, the pie chart, stacked bar, stacked column, and area graph will solve the purpose. And if you want to understand the distribution of your data, to understand outliers, the normal tendency and range of information in your data values, you can use a histogram, density plot, maybe box plot or volume plot. And finally, if you want to show as how one variable relates to one or more different variables, that is, one variable has a positive effect, has a negative effect, or has no effect on other variable, then the scatter plot, bubble plot, and line plot are good chart types to use. Anyways, don't worry, this is what we are going to learn in this as well as in upcoming sessions of data visualization. And of course, we'll be using Matplotlib and Seaborn libraries for constructing all these charts. We'll start with Matplotlib, which is a Python library used for plotting graphs with the help of other libraries like NumPy and Pandas. At the end, we will also get the flavor of Seaborn, which is also a Python library built on top of Matplotlib. Okay, so before writing code to create a graph, let us understand the Matplotlib object hierarchy. First of all, the figure object. The figure object marked by this red box over here. is like a canvas. Everything that we want to draw will be on this canvas. A figure object can contain multiple axis objects, and the axis object is marked with a blue border over here. This is where the data will appear. Right now this figure object contains only one axis object, however it may contain more than one axis. And every axis object normally has further two axis objects, axis with an I, AXIS, the x-axis object and the y-axis object, as shown in green over here. And finally we have the artist, which is further a collection of objects like the title of the graph, the legend, the grid, major and minor ticks along the x-axis as well as along the y-axis, the x labels, the y labels, the lines, the markers, the spines, and so on. Okay, so with this brief overview of the anatomy of a figure, let's see the learning agenda of today's notebook. Well, we are done with the overview of data visualization, choosing an appropriate chart and discuss the anatomy of the figure. And we are left with downloading and installing Matplotlib, writing code to draw our first chart in Matplotlib, which will be a line chart. And of course, we will start with a very basic chart and we will enhance it step by step. We will enhance it by adding a title to the chart, setting the XY labels, modifying the ticks, adding multiple lines in the graph, adding the legend, use of line markers, improving the line attributes using annotations, and finally we will save the graph on disk. Okay, great. So my dear students, Matplotlib does not come pre-packaged with Python, so you need to download and install it using pip install matplotlib. And the version that I am using right now is 3.4.3. And once you have downloaded and installed Matplotlib, you can import the PyPlot module of Matplotlib as a PLT. And later on you can check out what all the functions and constants are available after you have imported this PLT using the dir function. You can see there are dozens of methods that are available in the current namespace now. Okay, my dear students, before we proceed, there are two ways to program in Matplotlib, a stateful approach and a stateless approach. First of all, let's talk about the stateful approach. Let me create a dataset first. Let me say import numpy as np, and let me say create some x points, np dot linspace, and let me say start from -2 to +2, and let me create 20 floating point values between these two ranges, and these are the x values. Let me say the y values as x power 3. So these are the y values, and you can check out the x and y values. So we have the x values and the y values. Great. And now if you want to plot, you use the plot method of pyplot, plt.plot. So this is the method using which you are going to draw a line graph. You pass it the two values x and y. So these are the points, 20 points. They will be drawn in the Cartesian coordinate, and then a line will be drawn to connect all those points. And after this, I just need to say plt.show, and let me run it. Great. My dear students, in Jupyter Notebook, you don't have to call the show method of pyplot explicitly. However, if you are working in some code editor or IDE, the plt.show method is required, which will display the graph in a separate window. Okay, so you can see along the x-axis we have values from -2 to +2, and along the y-axis we have values from -8 to +8, and this is the line that contains all the 20 points that I have created over here, the data points. Okay, so this is great. Now a $100 question is why this approach is called the stateful approach of plotting. My dear friends, we are using this PLT object, and it always has a current state describing which figure we are currently working with, and within that figure which axis we are working with. And right now we are having a single figure and a single axis, but there can be more. In this approach, whenever you want to make changes to a graph, you do it by calling some appropriate method of this PLT object. And the changes are made to the current figure and the current axis. This will become more clear once you will understand this object-oriented approach. Let me say over here. Let me say PLT dot figure. So this figure method is going to create a figure, and it is going to return me a figure. You see. So I have created a figure, and on this figure method object, I am calling add underscore subplot. I'm calling this add subplot method, and it will return me an axis. You see, so this has returned me an axis. So I have a figure, and within that figure I have an axis. So within that axis I can plot my data and so on and so forth. So this is the object oriented approach. And let me say now ax dot plot, and I already have the x and y values. Let me say plt dot show. Great. So you can compare both the graphs. They are exactly same, but this is an object-oriented approach. And in this session as well as in the upcoming sessions, we will be using this approach. So I will recommend that you should use this syntax instead of this one. Instead of using these two lines, we can always say fig comma ax is equal to plt dot subplots. So this is also the same. The subplots method will return a tuple, a figure object, and at least a single axis object, so which you can use to plot. I think this makes sense. Fine. So let's see now. Let's take a sample data and keep drawing that chart, the line chart, keep improving it, so that after 10 to 15 minutes we have a fair understanding of how we can build a line chart from the grassroots level. Okay, my dear students, let's suppose that there is a company, Lahore Chemical Industries, and they have given us their export data of chemicals for 12 different years. In million US dollars. The company wants to plot this data in such a way that shows trends and how the data has changed over time. So these are the years, and these are the amounts of exports that they have done. So line chart is the best option, which are drawn by first plotting these data points on a Cartesian coordinate grid and then connecting them with a line. And typically the y-axis has a quantitative value, while the axis is over here a time scale or sequence of intervals. Fine. So we have this. So let me create a figure object, plt dot figure, and on this figure object let me call add underscore subplots, plots. Okay, so it will return me an axis. Let me receive it in ax. Great. And now let me call ax dot plot, and let me pass years along for the x-axis and chemical exports as the y-axis, and let me say plt dot show. I think this will do the job. Oops, we have an error. Subplots, add subplots. We don't have to say add subplots, we just have to say add subplot. Great. My dear friends, remember the only required argument to this plot method is the data to be plotted on y-axis. We are passing years as the x argument and the chemical exports as the y argument. Great. So this is a great chart. Fine. Let's try to improve this chart step by step. Let's see that how can I add a title to this chart over here, uh, which should say that what this chart is all about. Let me copy this code, move down a little bit. Now we are going to enhance our this basic chart step by step. And the first thing I'm going to do is I'm going to add a title to the chart. And to add a title to the chart, I just use plt dot title, and let me say LCI exports in last 12 years. So let me run it. You see? Great. So this job is done. And next thing I want to do is I just want to add the X and Y labels. I just want to label these X. I want to say that these are years and these are probably $1 million amount in $1 million. So let me copy paste this thing over here, and for that what I need to do is I need to say ax dot set underscore x label. Yes, and what I want to keep over here is years, and ax dot set underscore y label, and what I want to say is amount million US dollars. Great. I think this will do the job. Let me run it. And great. So we have the X label as well as we have the appropriate Y label. And let me modify the ticks as well. Although Matplotlib sets the ticks on both these X axis as well as on the Y axis, and these ticks in most of the cases serve the purpose. However, if you want to modify them, you can modify them using the X ticks and the Y ticks method. So let me just copy this and modify the ticks. And to modify the ticks, what I want to do is I need to have an array of values which I want to keep over here. Let me say xval is equal to np dot a range, and let me start with 2011 to 2022. Okay, not inclusive of course, with a step of 2. And for the y vals, I just want to keep np dot plain space, and let me say start from 0.8 0 to, let me say 0.98, and let me say that I want to have, let's suppose 10 values over here, equally spaced 10 values. And then let me just assign it ax dot set underscore x ticks. Okay, and let me pass it xvals, and let me say ax dot set underscore y ticks and y vals. Great. I think this will do the job. Great. So we have from 2011 to 2021, and we have around 10 values over here. Great. So we have successfully modified the ticks. And let's see that if we can add multiple lines in a graph. Well, if we want to add multiple lines in a graph, we need to have multiple data. Okay, so Control C, Control V. So do we have multiple data? Yes, we have medicine exports data over here. Come up over here. Yes. Let's suppose that this is medical exports data. This is another data set that the company has given to us, and he said that our company is not only exporting chemicals, but it is also exporting medicines, and in the last 12 years, the data of the medicine exports is shown over here, and they want us to plot this data as well over there. So for that, I just need to do what? I just need to do another plot, ax.plot. With years, I need to say medicine exports. So this is a change that I am bringing in over here. And in this figure, I am having a single axis, and within this axis, I am calling plot twice. And since I am calling plot twice, it will have two lines over here, you see. So this is the chemical exports, the previous one, and this is the medicine exports, the newer one. And Matplotlib has intelligently given it two different colors. Great. So we still don't know which line out of these show which specific information. So we need to add a legend to this graph, which will represent that this blue line is giving information about the chemical exports, and this orange line is giving information about the medicine exports. So we need to add a legend to our graph now. Okay, so let me copy this again and come up down over here, and let me add a legend. And for that, it's very simple. I just need to say plt dot legend, and to this legend I need to pass a list of the two lines, and the first line is chemical and the second is medicine. Okay, so great, let me run it. You see, we have a legend over here. My dear students, this is one way of adding a legend to your graph. This method is a bit error prone, for the reason being the sequence should be the exact sequence in which these plots have been created over here. Over here, first we have created the chemical exports. So the chemicals is coming first. Then we have added the medicine exports, and the medicine is turning up after this. If we somehow swap these two lines or write them other way around, this legend will be swapped. So this is very much error prone, that you need to keep tracking of this point, that if there are 4 lines in your graph, the sequence of addition of those 4 lines should be the same in which I have mentioned them inside this legend. So the better way is that you mention these labels over here where you are plotting it. So let me show you this second option as well. Let me copy paste this over here, and let me say that ax.plot years chemical export, comma, and let me say label is equal to chemicals, and let me say over here label is equal to medicines, and over here I don't need to pass anything right now. Okay, so this is more I think trendy and better. Now whatever sequence you have added these lines in, it doesn't make any difference. You just call the legend method of PLT and it will add the legend appropriately. One more argument to the legend is that you can pass it a location. Let me say that upper left, so it will move it to the upper left. If I say upper right, it will move to the upper right. If I say lower right, it will move it to the lower right. So there are a lot of options, and the best is the best option. So it will intelligently paste it to the most appropriate place. So great. So this is how we can add a legend. My dear students, if you ask me in this graph the amount of medicines exported in the year 2016, it might be a bit difficult to guess because we do not have a tick point for 2016. So I have to judge it like this. So for this we can use markers for different data points on the line using marker argument to the plt.plot. So make use of the markers. Please do visit this uh, website of Matplotlib where you have a lot of types of markers which you can use. So let me fall back over here and let me copy this and let me paste it over here, and let me tell you how we can add the markers. You just over here after this label, let me say marker is equal to, let's suppose I say O, and over here let me say marker is equal to, let's suppose X, and let me run it again, and you see the markers. Great. After the markers, you can always set the attributes of the lines as well. The line's colors, the line style, the line width. Let me copy it again and show you this as well. Okay, so let me say over here now, the color is, let's suppose, let's say that the color is blue. If I want to keep blue color, okay, so the color is blue, and the line style is let's suppose a solid line. If you want to keep a solid line, keep a dash over here. If you want to have a dash line, put two dashes over here. If you want a dash dot line, so put a dash and then a dot over here. And if you want simply a dotted line, then you just put a colon over here. So let me put a solid line, and let me say the width of the line is 2. Okay, and over here let me change color is equal to, let's suppose red, and let me say the line style is let me say a dotted line this time, and the line width is, let it be 2. Okay, so let me run it. You see, so note the line width has gone 2. Over here we have the dotted line. This is blue, this is red. It's great. Of course, but in some Python programmer, instead of passing these arguments like this, which is to me more readable, make your code more readable, they prefer using a format string by passing the marker line and the color to it. And for completeness, let me show you that as well. Okay, so over here, and they just pass it as the third argument, O-G. So this is it, and you need not to pass these over here, need not to pass these over here, and let me say X hyphen R. Okay, I think that's okay. Oops, sorry for this typo. So job is done. So this is also simple, but I personally prefer using it this way, explicit passing the arguments. Okay, so what else? Changing the figure size. Okay, so my additional, you can always change the size of the figure, and if you want to do that, just pass this fixed size argument and pass it a tuple, let's suppose 12,6, and you see this. I've just passed the fixed size, and the size of the figure has been changed. And of course, you can change the grid as well. We don't have a grid over here. If you want to add a grid, just say plt.grid and plt.grid and pass it a value of true. So you see you have a grid available over here. So this is very simple. Really, it really looks good now as compared to the first chart that we created in today's session. Okay, let's talk about the annotations now. Okay, so what do you mean by annotation? My dear friends, you can annotate your graph by writing specific text at a specific data point for highlighting and describing some specific data point. For example, let's suppose that I just want to mention some text over here that this is the highest peak of export in the chemicals of LCI that have been achieved in 2016 over here. So let me annotate this point. So to do that, you just use the annotate method. So let me say that something like this: plt dot annotate, and let me say peak of medicine exports. So no, this is chemical exports. Okay, peak of chemical exports, exports exports. So this is what I want to say, and I want to say it at location xy is equal to 2016, and let's suppose 0.95. Let me pass a tuple 2016 comma 0.95. Great, I think this will do the job, and that is it. So you can see I have used just two arguments, the text and the xy location over here. So this looks really great. Okay, my dear friends, we can have built-in styles as well over graph, and the built-in style, if you want to see the built-in styles, just say plt dot style dot available. So these are the different built-in styles that are available to you. You can just use them instead of putting in that much lot of effort. Just copy paste, and let me say, okay, over here let me say plt dot use, and which one we want to use right now is let's suppose I say grayscale. So this is the grayscale, not much difference. Let me say ggplot. So this is a bit different. Let me say, okay, classic. Okay. So by just changing the style, you can change it. And if you want to move back to default, so move back to default. Great. Great. Finally, my dear students, I think that is enough. We just need to save our graph now. Let me save it onto disk, and it's very easy to save it on disk. You just need to use the save fig method for that, and let me say that plt dot save fig, and let me name it, let's suppose my chart dot png, whatever extension you seems feasible, and let me run it. And remember, you need to save it before the show method. If you use it after show, the image is closed and freed from memory and nothing will be saved. Okay, so let me check out. Let me check out ls-l my chart dot png ls-l. Okay, so this chart do exist over here. Excuse me. Okay, before we close, let's discuss about subplots as well quickly. So this subplots method is used to explicitly create a figure and an axis object. If you don't pass any argument to the subplots method, it will create a single figure and a single axis object. On the contrary, over here I am passing n rows is equal to 2 and n columns is equal to 2. So it will create a grid of 4, you see. And if I pass n col is equal to 1, it will create a figure having two axes, one axis and a second axis. And if I say, let's suppose 3, So we will have something like this, and if we say something like this, so we will have something like this. So this is great. You can create any number of rows and number of columns, and within that you can create appropriate graphs. So this is a great facility. And right now over here I have shown you this thing over here. So we have two line charts, the one line showing the chemical export and the other line showing the medical export. Over here, instead of creating one figure and having one axis, and within that one axis I am creating two lines. Now I want that I should have two axes. So I have called subplots, and I have called n rows is equal to 2 and n columns is equal to 1. So we have two rows and one column, and we have two axes, ax1 and ax2. And on ax1 I have plotted chemical exports, and on ax2 I have plotted medicine exports. And the rest of the code is more or less same, and we have different titles and x label and so on and so forth. So you see, so this is one figure, two axes, two rows and one columns. Along axis 1 we have LCA chemical exports in the last 12 years. This is the title. And for axis 2 we have LCA medicine exports in the last 12 years, as mentioned over here. You can note the line styles, markers and so on. So this is how the subplots work. We have two subplots within a figure. And similarly, over here what I have done is I have created two figures instead of one. I have called subplots twice. And for figure 1 I have axis 1, in which I have shown you the chemical exports, and in figure 2 I have axis 2, in which I have shown you the medicine exports. So this is a bit different from the previous one. Over here we have now two figures. So we have two figures over here. I hope this is making sense. Anyway, great. So that was a lengthy session, first lengthier session on data visualization. My dear students, that is all for today's session. We will inshallah continue our journey to learn Python programming for data scientists in our next session. I hope today's session was informative for you all. If you have liked it, please subscribe my YouTube channel and share it with your friends. I wish you all the best, happy learning, and Allah Hafiz.